And now it's time for our first presentation in the Edge EcoCast. And this session comes from Scale Computing, and presenting for Scale Computing is Dave Demlow, who's Vice President of Product Strategy at Scale. Dave, welcome. Thanks for joining us.
Thanks very much for having me, and thanks for everyone who's joining.
Yeah, well, we're looking forward to your presentation, so take it away.
All right. So, I'm Dave Demlow. I've been with Scale Computing over 12 years and kind of seen an evolution in IT space, rapid cloud adoption and a lot of applications being moved up to the cloud. Now seeing, these new applications that don't operate well in the cloud environment. And that's really been a big focus of Scale Computing during that time and then we'll go into, some of the problems that you'll face in these distributed edge environments. But really, why are we here today? I mean, really, it's, still the same fundamental things that everyone in IT has been dealing with is, just the reliance on IT infrastructure, information access, using it to provide access to, immediate access to information anywhere, automating workflows that streamline business processes, and well as, more and more, and the Edge really has brought this, being able to deliver new and really engaging experiences for customers, employees, and so forth. And many of these applications are critical enough that when they fail, or when access to internet to connect to these applications, businesses literally stop. They may be things like a manufacturing line that is inspecting parts and making real-time decisions as items are being manufactured, or a retail self-checkout type application that cannot process orders and so forth. And we're going to talk about a lot of those different use cases and how they apply in the Edge, and some of the different ways that you can account for various levels of data resiliency, application resiliency, as well as cloud connectivity in your Edge infrastructure design. So, the first thing is, why not all cloud? I mean, I kind of touched on some of the point, why, cloud can be, provide instant scalability, the ability to quickly, rapidly deploy new applications that meet business needs. Why wouldn't you put everything in the cloud? Well, there's a bunch of reasons, and different use cases will expose, different constraints. One of them often is cost. And when you're dealing with applications that, involve large amounts of data, we're seeing a rapid growth in things like computer vision and video surveillance and analytics and things like that require processing very, very large data streams and sending all that raw data to the cloud to be able to do facial recognition and then send responses back. Costs a lot of money, as well as there's a latency time involved. Many of these new applications, for example, the manufacturing line can't take the time to send those large data streams over a remote connection, wait for a remote analysis to be done, a response to sent back. They need, sub-millisecond in many cases latency, but, certainly a few milliseconds of being able to make quick decisions and be able to maybe do that in cases where you don't have resilient internet connectivity or none at all. We'll talk about some use cases that Scale actually has a number of customers deploying, things like ocean-going vessels that have intermittent connectivity and very, very expensive high latency networking, but yet have these needs for critical on-premises applications. And then often it's a regulation issue when you're dealing with, moving data between, different political environments, different governments, different storage locations, or dealing with privacy information. All the computer vision, facial recognition type applications. Very often there are regulations that would prevent you or put your company at risk if you possibly expose personally identifiable information like medical information, or even in some cases just facial identity and so forth. So as I mentioned, I've been with Scale a long time. I've been in the IT space for, really my entire career. And so can't say the mainframe piece, but, I jumped on board, right in kind of the client server computer phase, not to age myself, things like Novell NetWare and early, Windows NT, and even things like OS2, client server computing, where you had very centralized environments or decentralized environments, still often connected into, some central mainframe or BMS or, microcomputer, things like that. Saw, that client server computing start to see the benefits of centralization and things like shared infrastructure, shared storage, standardized IT practices, and including, some of those being moved into cloud type resources. So still central data centers, but instead of building, corporate large and managing large corporate data centers, leveraging economies of scale in centralized cloud providers, and many applications that made sense. I mean, hosting an email server locally on-prem or in multiple offices just doesn't make any sense whatsoever in this kind of world. But just 10 years ago, running Microsoft Exchange on a box in every office was a very, very common practice. That's all obviously moved to the cloud. But what we've seen is this, emerging edge computing, and it's in many cases driven by net new applications that just weren't possible, years ago. Things that rely, as I mentioned, on, on-premises AI, machine learning, computer vision, doing, real-time analytics and inference and so forth on the edge that are critical and require a new way of thinking of IT. So what is the edge? Just, our definition is it's the location where mission-critical applications and infrastructure run close to or outside a central data center, and that would include cloud. So if you're running, an application on premises, whether it's in one location or whether it's, 1,000 locations like a retail store, if you're running an application that's mission-critical, close to where that data is being generated or close to where it's being used, like a retail store or a manufacturing facility or an ocean-going vessel or on and on and on, that's the edge. And that's what we're here to talk about today is how do you run those applications. Often they are distributed, often they are in places that do not have IT, and that's where the issues really get compounded. We do often see these edge computings are multiple locations, and tens, hundreds, or thousands of locations is not at all uncommon in our customer base and the customers that we're selling to. And that introduces all sorts of technology issues, all sorts of people issues, all sorts of concerns over downtime. It's just, if you've got 10,000 sites, pretty much, even with the best IT practice, the most resilient resources, you're going to have something that needs attention, some monitoring that, at just about any time, something that you need to do, whether it's a simple failed hard drive that you need to, get shipped out or replaced eventually, or, a new application that you need to deploy. All those things become much more difficult and challenging across a distributed edge environment with lots of locations than, for example, deploying a new application on a central cloud. And that's really the gap that we're trying to bridge in our environment. We'll talk more about what we do. So, edge deployments, the things we generally see, we see a lot of physical infrastructure, and often these are physical point solutions. A lot of times people don't even know how many of these things they have. We'll talk into an environment and they may be bringing us in to consult about some new computer vision applications that they want to deploy, and they're looking at what kind of hardware they need. We'll look around or ask around, and it's like, well, what's that thing over there? Oh, well, that's the box that controls the, monitors the freezer temperature. And, oh, that's the server that is the back end for the point of sale system. And, oh, that's the video security system. All those different things, that would rely on physical infrastructure. We also do see in more mature or larger scale environment, the use of virtualization. And often it's, either things like, just two mirrored hosts with some, manual backup restore type capability or things like that. Generally not, automated high availability in a lot of cases. Or a 3-2-1 or 2-2-1 infrastructure where you've got multiple servers, a shared storage environment that does start to provide, data failover and so forth there. And, for those of us in IT who are familiar with these environments, there's a lot of trade-offs, a lot of complexity in managing those. And so, one of the things we talk customers through is kind of this concept of an availability index. You can do lots of things from, start with a single server, single box, fortify it with RAID or different storage. That gives you a certain level of availability at a certain price point. You can, do replicated pairs that give you, if you are actually doing mirroring with some level of ability to quickly switch over, some level of higher availability, but at a much higher cost. You're doubling everything. You're getting, at least, double the resources. And very often what we see is these are, fortified servers. So you're already doing, RAID. You're already, doing a lot of built-in hardware redundancy for that. And then, replicating, mirroring everything twice. We tend to, one of the things that we're very good at are these 3-node configurations and providing these 3-node configurations with smaller devices that are small form factor, lower cost, that are really well tuned. And to where very often the 3-node system is less than the cost of replicated pairs, and you get much higher availability and a much higher utilization, because you're not like having a full standby system sitting there doing nothing most of the time. So we can walk customers through, and we offer solutions in all these spaces depending on the need of the application, but being able to have the same system, same management infrastructure is really key. And so kind of introducing our entire platform. The product suite overall is called Scale Computing Platform, and what we provide is this all-in-one infrastructure that is cloud managed, centrally managed. So we just introduced a product last year called Scale Computing Fleet Manager. That's your centralized cloud-based management and orchestration at scale. We'll talk about some of the capabilities. And then for the on-premises systems that it manages, this is, it's hyperconverged, meaning that the systems you buy fully integrate the storage, the compute, the virtualization stack software, the ability to run containers, the ability to do, snapshotting, disaster recovery, replication, all those things built in on premises. And as I showed in the previous slide, different sizes, resilient configurations that let you kind of pick and choose what you need at each location for each application. And where applicable, we can help customers consolidate all those individual piecemeal point solutions into a single centrally managed platform. Different ways of doing this, doing virtualization. I'm not going to spend too much time on this. We can go deep. In our hyperconverged solution, that's really, again, the architecture that integrates all the compute and storage together. There's a bunch of different ways to do that. One way is to basically take what would have been a shared storage system, a device, virtualize it as a VM, that's called a VSA or virtual storage appliance, run that on every system you have out there, and then aggregate the storage together. So basically you have a software SAN and a big workload that's running on top of that. Doing that, one of the downsides or one of the considerations on the edge especially is that VSA application requires an enormous amount of resource, a lot of RAM for caching, a lot of CPU cores to serve up the storage. I mean, it's basically doing all the network protocols. It's using iSCSI or it's using NFS or, those kinds of things just to provide storage to applications that are running locally. We designed and developed a fully integrated HCI model where the storage layer is built right in, and that makes it very, very efficient. So on the bare operating system that we provide in the appliance on the metal, that provides the storage stack. There's no external storage protocols. There's no virtual storage appliance. So we just use a fraction of a core processing for that and very little RAM per system in order to provide hyperconvergence. And when you look at our product line, we have systems that go down as small as 16 gigabytes of RAM and just a few cores, which is more than adequate for a lot of edge applications. And it's very, very important that you be efficient on your resource utilization in those cases. Again, we designed this edge solution cohesively from the ground up, really, and have been expanding it for more than a decade. So we understand, the environment that exists in the edge. There's very often limited or no IT staff. And so we recently introduced zero-touch provisioning, where the central IT team can configure what that system is supposed to be, ship it out via UPS, have a store manager or somebody with very little training, plug in a power cable, plug in a network cable, have the system phone home and configure itself in your fleet, and then configure applications. Very often there's physical constraints on just the size or the power consumption or the heat dissipation of a particular environment. So we have devices that are designed to be very small. If you're familiar with the Intel NUC platform, we have an enterprise version of that, the little 4-inch by 4-inch cubes that can cluster together for high availability and run, an amazing, impressive amount of applications. Solutions that run autonomously, so they can handle connectivity outages. They can keep the application running locally, even if there's limited or disruptions in internet connectivity. And then being able to handle unpredictable demands. And unpredictable demands could be, an influx of data that needs to be processed, and that might require, deploying new nodes in this case, and scaling out the hyperconverged infrastructure very easily and seamlessly. That could, also just be things like, new applications. We find, very often our customers, once they have this centralized infrastructure and they see how easy it is, that is basically as easy to deploy a new application in a matter of days or weeks versus, months or years out to a large distributed environment. That just enables them, once they know that they have that ability, the business units just want to be able to, get these things out and as quickly as possible. So what we provide is infrastructure that cares for itself. Again, there's no IT personnel on site, so availability is built in to the architecture. Simplicity, being able to centrally manage these. Efficiency, as I talked about, making sure that the resources are available to do the work that you care about, the applications that provide business value, and flexibility. So the ability to have a wide range of systems, the ability to scale out what you need. And by the way, you can scale out with different systems over time. They don't need to be the same exact node type or same hardware configuration. You can mix and match, things like that. So we really took a lot of care in future-proofing the edge environment to be able to handle all these things that are needed today, as well as the things that are very likely coming. And we recognize that there's going to be cloud-based applications, and cloud is great for many of these things. There's going to be edge applications that are increasing to need resources, need compute, need things like GPU for inferencing and so forth. And we offer products that meet all of those needs, as well as we can help you connect those into those public cloud resources and services that are already there. Whether it's passing IoT data, whether it's leveraging cloud for training models that are then executed on the edge, things like that. We can offer all those solutions together. We talked about this again. It's an integrated platform designed for the edge, so you're getting from one vendor the on-premises piece that running your applications and all the capabilities built in out of the box. No separate hypervisor to go out and license, no integration to do on your own, as well as full automation to do that. So we talked about the fleet manager with the central monitoring and management. Other things that it does, it's the hub that provides that zero-touch provisioning that I mentioned briefly, so that when systems are deployed, they just phone home the fleet manager. They've already got all their instructions, their configuration. They come online. There's a new capability that we're introducing now called Secure Link, that from the Fleet Manager console, you can, without any VPN connection, drill right down into any of the edge locations, and for orchestration, for automation, for troubleshooting or whatnot. But really our goal is to provide that end-to-end complete edge, data center to edge, one integrated platform, and handle everything from day one initial provisioning, getting the workloads online with automation. We have an Ansible collection, for example, that can deploy and configure your applications fresh from scratch. Can handle things like importing existing applications. Can also handle day two operations where you need to expand resources. You need to add a new new application very rapidly out to the fleet. All that can be done in an automated way, which is really essential when you start talking about hundreds or certainly thousands of sites. So we've really focused on that. I mentioned, a wide range of platforms. So you can see on the left side of the screen that HE100 series. That would be a micro edge platforms. Those are actually based on the enterprise form of an Intel NUC, but they're very, very small but very powerful, and also very easy to consume. I mean, those are the kinds of things that literally with one network cable and one power cable and zero-touch provisioning, you can send these out without any IT people to plug in, bring itself online, phone home, and then handle all of the management remotely. We have that up to very high-end data center type machines, GPU loaded, NVMe storage, as well as specialized nodes that we've targeted for capacity type solutions like video surveillance, where you may have large retention requirements and so forth, as well as cloud platforms. And this is both our Scale Computing Cloud Unity platform that we provide. We've also, as I mentioned, spent a lot of times making sure that our solutions and the applications that our customers want to run can also integrate with the public cloud solutions of their choice. So, whether it's Microsoft Azure and integrating resources into Azure Arc, or Google Anthos running their Kubernetes distribution on premises, we've worked through all those types of integrations and can make those available to very quickly deploy those types of solutions. So with that, let's see if we have any questions here.
Yeah, Dave, we did, and I really like that sine wave that you showed early on for the sort of the oscillation between centralization and distributed computing over the decades. That's such a great representation. Yeah. And while we do see what questions we've got here, I will put up just a poll question about additional information that people would like to see about scale computing, and I'll also mention be sure to download the PDF in your handout section from Scale Computing. But yeah, let's get into the questions. So we have a few related questions from Peter and Jadip and some others on a theme, which sort of boils down to this: what are the primary drivers for running applications on premises at the distributed edge versus in the public cloud?
Sure. Yeah, I had a slide that kind of touched on several of them. I mean, but they're going to be very, business specific. I mean, often it is, in many cases the application just can't. We've definitely worked with customers that have tried, sending large amounts of data to a cloud, doing some processing there, waiting for an answer back, and whether it's the latency of round trip, whether it's the cost of sending all that data back and forth, whether it's the response time that's required, making these split-second decisions. That's kind of one class of problems. The other thing we do just see are, and I saw a couple of questions here on kind of the governance pieces of, can I send data from one country to another, or is there a cloud provider that's close enough that data sovereignty type of issues, or personally identifiable information, GDPR or California type restrictions, where being able to do all that processing on premises, where the data is secured, it's not traversing a network, it's not being sent to the internet, can have both those compliance benefits and cost, and then reliability. I mean, different parts of the globe, we have areas where internet can be cheap and resilient, and multiple connections aren't that much of a problem. So there's lots of areas that are 100% the opposite, where relying on at any moment having any connectivity, much less fast, robust, guaranteed latency connectivity, is just not available. But usually they fall into kind of those categories. Either the application just cannot be run at with the service level that's provided, or there's some kind of compliance or business or privacy requirements that dictates, we want to keep the data local and do the processing there. And then the other kind of interesting thing with Edge we find is a lot of that data then is by design thrown away. Once you've done the analysis locally, you've extracted the information you need, you've made that real-time decision that your application is needed, you've got the metrics, you've got the telemetry, and the telemetry is what's important, and that gets shipped up to a cloud for long-term storage. It goes to a data lake, things like that. But the raw data at that point, often is just ephemeral and doesn't need to be kept around.
Gotcha. Great. Get also some questions just sort of about, I guess, architecture and scalability. So this first one just comes from Sridhar, and I think this question came in before your graphic showing like the different levels of platforms. But that question was, do you have a hardware plus software, or is it a software only solution? So I guess the question is there a software only option, or is it all are they all like hardware or appliances?
Yeah, it's a tough one to answer. I mean, we are a software company, but what we have found is for especially edge reliability, we basically have a very strict, well-tested and maintained HCL that you don't even have to worry about. I mean, I think HCL is a bad word. But if you have to go out and worry about, hey, is this piece of hardware work with my software, or hey, I'm about to do a software upgrade, is my hardware compatible or not? That's, our customers and our prospects don't want to deal with that across a large fleet. I mean, so we generally sell as an appliance, but there are different channels that you can buy from, and in the end, we are a software, a software solution. But we make sure that it is available, and some does depend on your scale. So we have very large end user customers who have their own hardware platform, and if it's a sufficient scale, we will basically add that to our HCL, which for us means we've got a large number of systems in our labs. We're doing regression testing every time we make any changes. But from a quality perspective, we want to make sure that that we fully understand the details of hardware. And for those who have dealt with hardware levels, a hard drive is not a hard drive, and a flash drive is not a flash drive. And so we, down to, specific firmware versions, we do testing on those. We handle updates like, if there's a BIOS update for a piece of hardware that we provide or support, we actually will handle updating that and making sure that, it's upgraded as a unit with software that's been tested with it. So all those kinds of things that, especially across these large distributed fleets, will undoubtedly eventually shoot you in the foot. We handle all those for you. So in the end, it is an appliance. How it gets to you can vary a little bit, but the general thing is an appliance with the software preloaded. So like I said, it's a tough one to answer because it is software under the hood, but we guarantee that QA, that customer experience is generally delivered as an appliance.
Yep. Yeah, great. And before we get to the next question, I just want to thank everybody for answering this poll. But I'm gonna go ahead and switch back to this slide. I think for this question, it might make it easier to talk about.
Okay.
We have a scalability question from Edgar, who's saying, what are the scalability limitations on the stack? And I thought maybe this might be helpul to to sort of go through.
Yeah. Well, and scalability means a whole lot of things. So I mean, we have nodes that go into multi-petabyte type on-premises clusters,
Yeah.
and then I guess scalability from the fleet standpoint. We have customers well over 1,000 sites with often multiple clusters per site, and a fleet of 10,000 plus 50,000 locations is. Our goal is to make that manageable. And I think I saw another question about, well, is it harder to deploy remotely on the cloud? Obviously, yes, things are different, but our goal and with the automations that we provide, if somebody came to me and said, hey, our problem is we have a new container application we're building. We want to be able to deploy it, daily build, update, push it out, across 10,000 locations. We do that. We will manage the hardware for you. We will manage the deployment of, those applications, the updating of those applications. We have, the automation tools to, handle things. I saw there was a question about patching and software updates. That's why we have all those interfaces. So, the Ansible collection, for example, that, not only can help you orchestrate the fleet, can also be the same tool that goes in and does Windows updates if you're a Windows customer, or deploys new containers or patches or things like that. And so you can use one kind of tool stack to orchestrate one site just as easily as 10,000 sites. And but again, from the hardware standpoint, I think I covered individual nodes. We have nodes that are designed for GPU, VDI computing, that are designed for high capacity storage retention. That have a 18 terabyte drive sitting in them, and that cluster together and scale out, and for video surveillance and retentions.
Yep. Okay. Super. That's great. What types of applications can I run on SC HyperCore?
Yeah, and really our goal is we want to be the platform for all your applications, so that you don't need to deploy or manage point solutions and deal with the hardware, deal with the operating system stack, things like that. I mean, and so, the simple answer is pretty much anything that runs on x86, infrastructure. So, Windows, Linux, we do certifications with all the major vendors there. We have a support matrix of all the versions that we test with there. And then, any applications that run on top of that. Also, as I mentioned a couple times, container, Docker runtimes, OCI container runtimes. Just if you're doing Kubernetes at the edge, and there's some interesting, we've worked with, basically any flavor of Kubernetes. K3s is a very popular Kubernetes distribution for the edge, and we have the tools and so forth that can help you both deploy applications onto those, keep those up to date, whether it's, legacy virtual machine workloads. And, we find, a lot of customers, the key is they have both. There's a lot of in manufacturing, some very, very old Windows boxes that, talk to very, very old PLCs, and those have to be there for a while. And, yet there's, new type of, IoT applications that are often containerized and so forth. And we want to be the infrastructure that lets you manage those and deploy those and update those across any number of sites very easily.
Okay. All right. Well, Dave, thanks for being so generous with your time. Really appreciate all these insights here in the Q&A and in the presentation. And just one last one. If somebody wants to get started with Scale or find out more, what do you recommend that they do?
Go to our website, scalecomputing.com. We've got, lots of great resources there. And you can chat with us online, or get in touch with someone, and they can assess your environment, assess your needs, find, similar case studies, vertical markets, things like that, can help kind of as a blueprint for customers that have done similar type of things. And but that's where I would start.
All right. Well, Dave, thanks again. Really appreciate you coming on.
Thank you much. Thanks.